Hello students, so welcome to one more video. So today we are going to discuss about one more topic from the chapter of friction from class 11, and this is a very controversial question. Which is easier, pulling or pushing a roller? Okay, now often when I ask my students that which is easier, pulling or pushing, now if you ask simply which is easier, pulling or pushing, there is no particular answer. Why? The answer I will give at the end of the video. Okay, so if I just ask which is easier, pulling or pushing, so there is basically no particular answer. You have to mention the object. Okay, which is easier, pulling or pushing. In this particular video I am going to discuss which is easier, pulling or pushing a roller. What is the meaning of roller? Roller means, I hope all of you have seen, suppose wherever you have school playgrounds and all, there is a roller which is used to level the ground. Okay, it can be pulled. It has a handle with it has a it looks like an iron cylinder actually with a long handle, and it can be either pulled or pushed. Fine. When I ask my students which is easier, pulling or pushing a roller, okay, so most of you will say pulling, some of you may say pushing. Okay, it depends upon the answer. But what is the actual physics behind that one? Okay, what is the actual physics behind that one? Let us understand, and the concept. Now to understand this, you have to understand friction also, because friction also plays a very vital role in this particular thing. Okay, so let us see. So which is easier? Which is easier, pulling or pushing a roller? Pulling or pushing a roller. Fine. Now over here you see I have named roller. Okay, remember the name of the object, roller. I am not mentioning any other object. So why I am stressing on the name, I will tell you at the end of the video. Let us understand what is the basic concept. Okay, basic concept and the basic physics behind this one. Which will be easier? Now when I ask the word easier, first of all you have to understand there is no such thing in physics that is easier. This is a very subjective thing. It depends. Easier means, what is the meaning of the word easier? Okay, so let us see what is easier. When you are asked the question which is easier, because something which is easy to me may not be easy to you. Okay, so how to find out which is easier? So what is the basic thing behind this one? So this is a roller, suppose. This one is a roller. This is a roller. Fine, this is a roller. So first, let us see if I pull the roller. So pulling the roller. I want to pull the roller. How I will pull the roller? In this particular direction. I want to pull the roller at an angle theta. Fine. If I am pulling the roller, let us see what are the forces that are acting on the roller. What are the forces that are acting on the roller? So this is mg. This one is mg as usual. So I am pulling the roller on this side. This is theta. But this is mg. This one will be r. This is r. Okay. Now this F, this external force F, I can divide into two rectangular components. So one component will be acting in this direction, which is along the direction of r. Another component will be acting in this direction. Okay. So this is going to be F sin theta. This is going to be F cos theta. Now see, what are the roles of this component? You have to understand this one. F cos theta along with r is going to balance the mg. Okay, so that is why when I am pulling the roller, there is no vertical motion of the roller. Okay, when I am pulling the roller, there is no vertical motion. So F sin theta along with r is going to balance the weight of mg. Fine. This F sin theta is going to cause a motion in this direction. Okay, this F sin theta is going to cause a motion in this direction. Now all of you can understand, if the motion is in this direction, obviously friction will start to act in this direction. This is Fk, kinetic friction. Fine. Now let us see the equations behind this. So the equations behind this, you see. So along the vertical direction. So r plus F cos theta will be equals to mg. Fine. R plus F cos theta is going to be mg. Fine. So this is solved. So from here we can find out R. R will be mg minus F cos theta. R is going to be mg minus F cos theta. Fine. Along the horizontal direction. So horizontal direction, you see, along the horizontal direction, F sin theta is going to be the frictional force, F sin theta. Okay, because I am not considering the acceleration yet. I am just considering that this F sin theta is equal to the frictional force. Fine. Now see, we know frictional force is going to be, because over here now the maximum friction is acting, so frictional force is going to be mu k into R. This is the frictional force, mu k into R. So how much frictional force will be acting, or I can say okay, kinetic or limiting also you can say, no problem. So frictional force will be equals to mu k into R. R is mg minus F cos theta. So this will be the frictional force which is acting. Okay, so this is going to be the frictional force which is acting when I am pulling the roller. Okay, when I am pulling the roller, this is going to be the frictional force. Okay. Now what is going to happen if I am pushing the roller? See, if I am pushing the roller. So if I am pushing the roller, what is going to happen? So this was our roller. Suppose I am pushing it in this direction at an angle theta. Okay, I am pushing it in this direction at an angle theta. So what are the forces that are acting? This is F. Fine, this is F. Okay, this angle is theta. This is your mg. This is our R. Okay. Now this particular force, if I want to divide into two rectangular components, one component will be along this direction, another component will be along this direction. Those who know vectors, they will understand that if this force is acting along this direction, one component will be along this direction, another component will be along this direction. Okay. So this will be F sin theta, this will be F cos theta. Okay. So if I am applying the force in this direction, the motion will be along this direction. Okay. Why? Due to this particular component. Now see, F cos theta is acting in downward direction. Mg is also acting in downward direction, and R is acting in the opposite direction. So basically R is balancing F cos theta and Mg. So that is why there is no vertical motion of the roller. Okay, that is why there is no vertical motion of the roller. Fine. And this particular component, the horizontal component, F sin theta is producing a motion in the block, in the roller, F sin theta in this direction. So obviously friction will act in this direction. Fine. So this is the direction of motion. This over here, this was the direction of motion, and over here, this is the direction of motion. Okay. Now see, let us solve. So in the vertical direction you see, F cos theta and mg, these two are acting in the same direction, which is balanced by R. R is acting in the opposite direction. Okay. In the horizontal direction, F sin theta will be equals to Fk. F sin theta will be equals to Fk. Now we know that, as I said earlier also, over here I am not considering acceleration, I am just considering the force being applied, and the body has just started to move. Or you can say that the body is moving with constant velocity, no acceleration. Okay. Now F sin theta, or you can write, we know F will be mu k into R. This is the maximum frictional force which is acting. So therefore F sin theta will be equals to mu k into R. Okay, F sin theta is going to mu k into R. Okay, or you can do in this way. over here I am writing Fk is going to be mu k. R, what was R? Put down the value of R, okay? Put down the value of R. R was mg plus f cos theta. Okay. Now students, this is the value of friction that is acting when I am pushing the roller, and this is the value of friction which is acting when I am pulling the roller. Now see which one is greater. Which one is greater? Well, what is the meaning of the word easier? Easier. You see, in physics there is nothing known as which is easier. Okay, it's a very subjective thing. Easier. Something which is easy to me may not be easy to you. But the value of friction is not subjective. It is objective. The value of friction. When you are pulling the roller, whatever frictional force is acting, if I am pulling the roller, same frictional force is going to act, isn't it? So the value of friction is not going to lie. So based on the value of friction, based on the values of friction, we can say which is easier. Okay, easier means based on the values of friction, in which case more friction will be acting. So based on the values of friction, we can understand which is easier, okay, or which is difficult. You see, in this particular case, when I am pushing, in this particular case, more friction is acting. You see, mu k mg plus f cos theta. In this particular case, less friction is acting. Okay, in this particular case, less, because mg minus f cos theta. Okay, so that is why I can say pulling will be easier. Pulling will be easier. Easier means, I am telling again, what is the meaning of the word easier? Easier over here does not have any other meaning. Easier means friction will be less. Remember this one. Friction will be less. Now students, what is the basic physics behind this? What is the basic physics? Why this is happening? When I am pulling, because apparently it may seem that, if some roller is there, apparently if I push the roller, then only it might seem, because many students give me this answer, so sir, when I am pushing the roller, that time only it obviously it seems that it is easier. When I am pulling the roller, I have to walk in the backward direction. Okay, but the question is not walking in the forward or in the backward direction. The question is what is basically happening when you are pulling and when you are pushing the roller. If you have observed my diagram very carefully, you will understand. Okay, so once again I am basically telling you what is the basic physics which is happening over here. You see, whenever you are pushing the roller, this is the roller whose weight is mg. This is the roller whose weight is mg. Okay, and this is r. This is r. So whenever you are pushing the roller, you are pushing the roller in this direction. Okay, whenever you are pushing the roller in this direction along with a particular angle, this angle, or you can say this angle, any angle you can consider, then the components of the force will be in this direction and one component will be in this direction. This is your f sin theta, and this is your f cos theta. This particular component along with the mg will be balanced by r, so there will be no motion in the vertical direction. This will produce a motion in this direction. When you are pulling the roller, this is mg. Okay, this is mg. So when you are pulling the roller, in this direction you are pulling the roller. Okay, with an angle theta. So one component will be, this is your r. Over here one component will be in this direction, that is f cos theta, and here there is f sin theta. So this is basically getting balanced by mg, and this will produce a motion, as I said. Now see, these two diagrams, what is basically happening? You see, when you are pushing the roller, in this direction, when you are pushing the roller, one component of your force is getting added up with mg. You see, one component, that is the f cos theta component, is getting added up with mg. So when you are pushing the roller, mg was acting, the weight of the body, it will always act. But when you are pushing, one component of your force is getting added up with mg. Okay, so the apparent weight of the body is increasing. What is apparent weight, students? Apparent weight is the reaction force which the ground is giving. This is the reaction force. Okay, so if f cos theta was not acting, in that case r is equal to mg. But now R is equal to F cos theta plus mg. So when you are pushing the body, one force is acting in the vertically downward direction. So you will feel that the body is heavier. Okay, you will feel that the body is heavier because the apparent weight of the body is increasing, and that is why your friction is also increasing, because we know friction depends upon the reaction force. Very, very important. Friction depends upon the reaction force. Okay, so in this case, one component is acting in this direction. So actually the body is becoming heavier. The apparent weight is becoming more. But you see, in this case, what is happening when you are pulling the body? Okay, when you are pulling the body, in this case, this one component is acting in the upward direction. So this is basically decreasing the weight of the body. Okay, this is basically decreasing the weight of the body. Over here, because the equation is going to be F cos theta plus R is equals to mg. So R will be equals to mg minus F cos theta. Okay, and in this case it will be R equals to mg plus F cos theta. So which one is greater? This is greater than this one. So this over here, one component is acting, it is increasing your weight. Over here, one component is acting in the upward direction, it is decreasing the weight. Okay, that is why the apparent weight is decreasing, and that is why, students, you see, pulling is easier. Okay, pulling of a roller is easier than pushing, because when you are pushing, one component is acting in downward direction. When you are pulling, so when you are pulling, basically you will feel that the body is lighter. Okay, when you are pulling, you will feel that the body is lighter because the apparent weight of the body is decreasing. So that was the explanation. I hope you understood everything. Now coming back to the last point, why I was stressing on the point roller, because you see, which is easier, pulling or pushing? It basically also depends how you are pulling or pushing. Okay, how you are pulling or pushing. A very important thing is one, the basic physics. You see, any object which is lower in height to you. Suppose any object which is in height to you or lower in height to you, when you are pulling the body, you will be pulling in this way or you will be pushing in this way. Okay, but suppose an object is here, this is an object, okay, this is an object which is bigger than you, okay, which is bigger than you, and suppose you want to pull the object, okay, you want to pull the object, and suppose you are pulling the object not in this direction, okay, not in this, you are not pulling the object in this direction, okay, you are suppose pulling the object in different, or suppose you want to push the object. Suppose over here, when the object was in lower size from you, you are pushing the object in this direction. But suppose now you are pushing the object in this direction. In this direction, if you are pushing the object. So in this direction, if you are pushing the object, you see the opposite thing is going to happen. If you are pushing the object in this direction, if you are pushing the object in this direction, so the opposite thing is going to happen. mg will act over here, R is going to act on this side. Okay, the components, the pushing components, one on this side will act and one on the, it will act on in the vertical direction, in the upward direction. Okay, so in this scenario, if you are pushing the object in this way, if you are pushing the object in this way, in this case, it is not going to be like this, it is going to decrease the weight of the body. So it actually depends which object you are pushing and in which way you are pushing. Okay, now suppose this particular object, you are standing over here, which is bigger in size to you. Now you want to pull the object. Okay, you want to pull the object. Now suppose you are pulling the object in this way. You are pulling the object in this way. Instead of pulling it in this way, you are pulling it in this way, in the downward direction. Now see what is going to happen. mg will act in this direction, R will act in this direction, and this component, one will act in this direction, another one will act in this direction. So over here, if you are pulling in this way, this is pushing, this is pulling. So in this case, if you are pulling, it is going to increase the weight, because one component is acting in the direction of the weight, and if over here, if you are pushing, it is going to decrease the weight. So in this case, you know, it's very funny. In this case, pushing is easier. In this case, pushing is easy. Okay, and that is the beauty of physics, students. You see, when you apply the correct physics, okay, correctly, you see things how they change, how they alter. Okay, so there is no particular answer for a definite, for a particular question. It can vary. It can vary how you are pulling the object or how you are pushing the object, and what is basically the object. That's why I have said roller is very important. Please see which object is given to you. Okay, because this is something which can apply in your day-to-day life. Okay, so don't just do anything, just observe the physics. Okay, just apply the physics. Whatever physics you are learning, my point is, whatever physics you are learning, understand the concept and learn how to apply them in real day-to-day life. Okay, so the object also matters, and that way of pulling or pushing also matters. I hope you liked the video very much. Okay, if you like the video, please like and subscribe. Thank you.